Welcome. Today we're going to talk about basic trigonometric functions. This is going to be a totally new concept for some of you, so you need to make sure you pay attention. And I would recommend writing these down on a sheet of paper so when you go to work on your homework, you'll have them for notes. Now let me explain what they are. Okay, when we talk about trigonometric functions, we're actually talking about right triangles, and we're talking about a ratio of two sides of a right triangle. Now, we got to be able to designate what sides we mean. The most important first thing I want to emphasize is in a right triangle, we have a right angle, and the side across from the right angle is called the hypotenuse. This out here is the hypotenuse, and I'm just going to abbreviate it HYP. Another way to think about the hypotenuse, it's always the side that does not form the right angle. If you'll notice, side BD and side BC form the 90-degree angle. This side over here, if I was to even just remove that line, you could still see the right angle. That line that doesn't form the 90 degrees is always the hypotenuse. Now, the hypotenuse will always be the same regardless of what trig function you're doing and what angle you're referring to. But the opposite and adjacent sides can vary depending on what angle you refer to. So now let me talk about the angle. First of all, this symbol right here is the Greek letter theta, sine of theta. Often math teachers use this symbol to represent an angle. When you see that theta symbol, which looks like kind of an elongated zero with a line through the middle, that theta always usually refers to an angle. So we're talking about some angle, theta. Now, when we talk about trig functions, the first thing I want to emphasize is we only take trig functions, at least as of today, of the acute angles in a right triangle. We are not going to take the trig functions of the 90 degrees. It'll always be this angle here, or it will be this angle here. And depending on which one we talk about, it's going to affect which side is the opposite and which side is the adjacent. So let's first talk a little bit about if we refer to angle C, this one right here. So I'm going to just mark angle C, and I'm going to do this. I want to say I'm going to take the sine of angle C, okay? And what that means. Okay, now what that means is if this is angle C here, I already know what the hypotenuse is. The side that forms angle C with the hypotenuse, this side here is the adjacent side. We're going to make this the adjacent side because it forms the angle with the hypotenuse. That leaves only one other side to be the opposite. Opposite's this side. And the opposite, another way to think about the opposite, it's always across from the angle you're referencing. We're referencing angle C, so across from that, or the side that does not form the angle, because the hypotenuse and an adjacent side form the angle. The side that doesn't form the angle we're referencing is the opposite side. So now what I would do to find the sine is I would take this length, whatever the length of this opposite side is, and I would divide it by the length of the hypotenuse. So let's give it some values now, rather than just those values. So it won't say opposite and hypotenuse and adjacent. What it's going to say is it's going to say, oh, let this equal 3, this is 4, and this is 5. And it's going to say, okay, what is the sine of C? Well, sine, as we look over here, is the opposite, which we said was this side, divided by the hypotenuse, which is 5. So the sine of C is the ratio 3 over 5. We're done. We have the sine. We just leave it like that. If we were asked to find the cosine of C, then we're looking for a different ratio, a ratio of two of the different sides. Cosine, if we look down here, is adjacent over hypotenuse. So it's not the opposite, it's the adjacent. So the cosine of C would be 4 over 5. because here's the adjacent, here's the hypotenuse, 4 over 5. If we were to ask to find the tangent of C, it now is going to be the opposite over the adjacent. So the tangent of C would be opposite over adjacent. Opposite was the 3, adjacent was the 4. It's going to be the ratio of 3 over 4. And so we have these 3 different ratios. Now, we took those sine functions with respect to C. I didn't have to use C. I could have taken them with respect to D, and then it would be different. So if I asked you to find the sine of angle D, it's going to be different than the sine of angle C. It's a different angle. But the ratio is still found by taking the opposite and dividing by the hypotenuse. But now we got to look a little differently. If I'm looking at angle D, this is still the hypotenuse. The hypotenuse never changes. But this side here, the side length of 3, is the adjacent side because it forms this red angle here. So this side now becomes my adjacent because I'm looking at a different angle. If this is my adjacent side, then across from the right angle, if I point across to the other side, this becomes my opposite side. So now when I find the sine of D, I'm going to take the opposite and divide by the hypotenuse. Right here, sine of D is opposite divided by the hypotenuse. It's going to be 4 over 5. So it's a different ratio than the sine of C. If I was asked you to find the cosine of D, again, we're looking at a different angle than C. We're looking at this angle here. Cosine is still the ratio of the adjacent over the hypotenuse, but again, the adjacent now is the 3. So I'm going to do 3 over 5, because 5 is still the hypotenuse. If I wanted the tangent of D, again, the ratio is still found by taking the 2 correct sides, but now the tangent, which is opposite over adjacent, tangent of D, opposite is the 4, adjacent is the 3, it's 4 over 3. So if you'll notice, these ratios are different than these ratios because I took the sine, cosine, and tangent of a different angle. Again, if you need to rewind that and watch that again and take notes, but I'm going to do another example, and I'm going to show you probably what's the hardest ones that you will see in today's homework, and that is they won't give you all 3 sides, they'll only give you 2 sides. So you might have to use Pythagorean's theorem. They might say something like this. They might say this length here is 2 times the square root of 5, and it's all right to have irrational numbers, and this side here is 2. And it will ask you something like, what is the, let's do the cosine of C for this new triangle? Well, the first thing I want to do is I want to find my cosine, which angle C I mean. C is this angle, so that if this is the angle I'm looking at, this will be the hypotenuse because it's not going to be different because it's still across from the right angle, right? This will be my adjacent because it forms the angle that I'm looking at with the hypotenuse. So this will be my adjacent. And over here will be my opposite, the one across from the angle I'm looking at. Now what I got to do is I got to look over here in my notes over here to say, okay, which one's cosine? Oh, this one's cosine. Cosine's adjacent over hypotenuse. Adjacent, I don't know the length of the adjacent side. That's where Pythagorean's theorem comes in. Now be very careful. The hypotenuse is the one that is by itself. In other words, a squared plus b squared equals c squared. So I'm going to use a variable to represent my unknown adjacent side, maybe x. I'm going to go x squared plus this b side squared, or 2 squared, is going to equal my hypotenuse squared. Now be very careful that you understand how to square roots and other numbers that are multiplied by them, and that's going to be squared. So let's figure out what this is. We get x squared plus 4 equals, well, what's 2 squared? 2 squared is 4 times, that's a times symbol. What is the square root of 5 squared? Right? If I take this square root of 5 and I square it, it becomes just a 5. It doesn't become 25. It could become the square root of 25, but what's the square root of 25? Well, that's 5. So again, I get this 4 times 5. So I'm going to come down here now so I don't get lost. I have the x squared plus 4 equals 4 times 5 is 20 minus the 4 over. And I get x squared equals 16. And then don't forget to square root now. X is 4. Now remember, I was using x to represent the length of this adjacent side. So now I know this side is 4 by using Pythagorean's theorem. Now when I go to find the cosine, which is adjacent, what's the adjacent side length? 4 over, what's the hypotenuse? 2 square roots of 5. 2 square roots of 5. Now, you will, if you type this into your iExcel assignment, you will get it wrong for a couple reasons. First of all, you can reduce. What is 4 over 2? Well, that reduces to 2 over the square root of 5, right? Because 2 goes into 4 twice. And then we have a square root in the denominator. We don't ever want square roots in the denominator. So how do we get the square root out of the denominator? We rationalize it. And I rationalize it by timesing it by the square root of 5 over the square root of 5, right? In other words, I'm multiplying by 1, and that's a multiplication symbol, not a subtraction. And when I do that, I get 2 times the square root of 5 divided by, well, what's the square root of 5 times the square root of 5? It's the square root of 25, which is 5. And there is your rationalized answer. So when you're working on your assignments, make sure you rationalize the denominators. Don't leave square roots in the denominator. Make sure you know how to square roots so they go away. And a lot of your answers will be these irrational form. And they will ask for that, an exact irrational form with a reduced fraction. If you have questions, please get on and ask me during my office hours at 1 in the afternoon, or email me and I can set up some time to get a hold of you, set up a personal Zoom time that we can work on these problems.